So as I was mentioning before this thing turned off, that if you notice it starts off with a lot of big numbers. I mean, these aren't so big, but especially when there's big numbers, it's a good hint to start off with GCFs, which is just factoring. Take out the biggest number you can. The way to cancel things out, remember that we cannot do this. You're not allowed to, if it's being added, okay, you cannot just cancel them out. Because 4 plus 6 is 10, right? 10 over 4, or 5 over 2. You just cancel out the 4's, then you're left with 6. That's not the right answer. So you're not allowed to cancel if you have an addition or subtraction. Now if you have multiplication and you cancel out 4's, that's okay, because if you did it the long way, you'd get 24 over 4, which does equal 6. So the idea is that the shortcut of just canceling out has to give you the same answer as if you did the long way. That only works with multiplication. So our problem is that everything is adding and subtracting. We need to make it into multiplication, and then we can cancel out and get rid of everything. So here we can take out an 8. There's an 8 in both of these. There's an x in both of these. And by doing that, this means 8x times whatever else. And that means we're able to cancel out the 8 and cancel out the x. So what's left over is x minus 2. And on the bottom, I want you to factor it according to what you have on top. So I'm going to factor this as 8x times 3. The reason I chose 8x is because it's on top. I mean, 6 goes into 24, 12 goes into 24, 2 goes into 24. There's a lot of ways to factor it, but look what else is above or later on diagonal and see what cancels. So by doing this, you can see that, okay, now since they're multiplication, right, this means multiply, I'm able to cancel things out. So you can only cancel out factors. Factors are things being multiplied. You cannot cancel out things that are being added, subtracted. Like you're not able to just to do this. That's being subtracted. You're not able to do this. That doesn't work. There's a lot of shortcuts people want to take because it looks like, oh, that makes sense, but really the rule is as long as it's multiplication, you can cancel it, and nothing else. Okay? And of course, rewrite your answer. X minus 2 over 3. And what this means is that if I picked some number like 1 and I plugged it in here, here, and here, I know the answer is going to be 1/3. If I did x squared times 8 minus 16 times 1 all over 24 times 1 and got that answer, it'd be the same thing as if I plugged in 1 right here. 1 minus 2 is negative 1, negative 1/3. So these will give us the same answer. This is just simplified. That's why they're equal to each other. They give the same answer. No matter what number I plug into here, if I plug in into here, it's the same thing. Okay. So on all these, that's what you'll be doing. It's just factoring, break them down to something equivalent. So always go for the greatest common factor. So what's the biggest number that goes into 12 and 40? And you 4? Okay. And you notice there's an R in both of these? Please write all this down. And then on the bottom, seeing how there's a 4R on top, I'm going to factor the bottom as 4R. And then times what?
2R squared.
The 2, which makes 8. So the 2 and the 4 make 8, and then we have an R, so we need an R squared to make R to the 3rd. And show me that this is canceling out. I want to see this just like yesterday. Show me the same thing on the top and bottom. And of course, whatever doesn't cancel, what's our answer? Now, notice that, can we cancel? Well, there's a 10 and 2. Do those reduce?
Yeah, but it's negative 10.
You can't do this because this is subtraction. So keep in mind that rule of what you're allowed to cancel. Only if it's being multiplied, like up here. This is multiplication, this is multiplication. That's why we're allowed to do this. If it's subtraction, like minus 10, you can't cancel out 10 over 2. This is 3r minus. You can't cancel out one of these r's with this r because it's all subtraction on the top. And you can't factor this anymore, which means you're done. So the biggest mistakes on here are rules that are made up just to make things cancel further than they should. As long as it's multiplication, you can cancel. Otherwise, not. So we can't take an 8 out of 12, but is there another number we can take out of 12 that goes into, yeah, so you can take out a 4, you're left with a 3n. 4 goes into 8 2 times. And that's all we can do. It wouldn't be wrong if you multiplied this back and had 2n plus 4. That'd be okay, but it's not necessary. Won't matter. Hey, try number 4 on your own. See how that goes. Okay, so the GCF on the top is 5. Is this correct? Kind of, but look what's left over. You see how you have a 3 and a 3 goes into both of these? So that's a sign that you didn't take out the biggest number. It's really tempting to say 15 and 45. Okay, 5 goes into both of them, but is it that the biggest number? No. So what we can do is take out a 3. So if you take out, we have a 5 that's already out. Take out another 3 out of here, and what's left? Yeah, it's like we took out a 15. So if we would have taken out a 15 from the beginning, we would have had 15 times r minus 3. I'm just showing you that if you happen to factor out and notice that this, what's left over, can still be factored, you don't have to really erase and start over. Just factor again. And then here we can say, I'll say, yeah, 5 times 10r. Only because there's a 5 on top. If there's a 25 on top, I would have done 25 and 2. Just depends what's already there. So we have 3 times r minus 3, 10r. So this is a good, right here, example of the greatest common factor. Not just a common factor. If you took out 5, that is a common factor, but not the greatest. Okay, can anything factor on the top on number 5?
No, on the bottom.
Now, what does the bottom factor to?
B plus 7, B minus 7.
B plus 7, B minus 7. And how do we know that? Yeah, this is b squared minus 7 squared. So we know there's a pattern for that. Now what happens if, like on this one, the top is completely canceled out? So what does it mean to mathematically cancel out when you're multiplying? You know, what is 2 divided by 2 actually equal? Yeah, equals 1. So if you cancel everything out on the top, leave a 1. There we go. Now there's one other small detail here. Ready? And that is that before I said I can plug in any number and I should get the same answer here. But you notice that if I plugged in 7, into here, what would my answer be? 1 over 7 minus 7, which is 1 over 0, which is undefined. So there's just, sometimes we have these little nagging things that, like, well, yeah, this is true, but sometimes there's some excluded values you're not allowed to use. Just want to bring that to your attention. I'm not going to have you do this for every problem, but just know that there are some numbers that may not work when you have variables on the bottom. I'll leave that one for you guys. Flip it over. I'm just going to do 1 or 2 on the back. I got you started. All right. So is there a GCF on number 7, top or bottom? Okay. No. And I'm relying that at this point you know that this factors to 2 binomials. The numbers on here are pretty easy since these are both 1s, so you just need to find what 2 numbers multiply to 18 and add to negative 9. Close, not 6 and 3, but negative 3 and negative 6. So after you factor the top, same thing as the other side. Expect to find an a minus 3 and or an a minus 6. So as you're factoring the bottom, it kind of leads you to maybe one of the factors. So when you're doing what 2 numbers multiply to 9 and add to negative 6, you want to consider negative 3 and negative 6 as possibilities because, well, if they're not one of those, nothing cancels. So what's the point? So yeah, on here you can see that what 2 numbers multiply to this, you'll get negative 3 and negative 3. So you see how, even though I'm using polynomials, the system is the same as if I was reducing a fraction from elementary school. Write it as a product or multiplication of 2 things, and anything that's the same on the top and bottom gets canceled out and equals 1. Make sure you write neatly so your A's don't look like 9s. Okay. All right. I'll go down to 13. That'll be my last one to show you. By the end of this and all of tomorrow, there's going to be a lot of these, and they're going to be much more difficult. You're going to have to do the GCF and the factoring all at the same time. So here you can see that just like on the first side, on side 1, there's a GCF. So the first thing you want to do is take out that GCF. How many times does 2 go into 96? Okay. 48. There's a 1 here, so we just need to find what 2 numbers multiply to negative 60 and add to negative 4. What do you come up with? What multiplies to negative 60 and adds to negative 4? Okay, so 10 and 6, what are the signs? Negative, positive. So negative 10 plus 6 is negative 4. Negative 10 times 6 is negative 60. So as you're factoring the top, look for either an x minus 10, which doesn't look like it because 10 doesn't go into 48, but you should probably count on an x plus 10 being a factor up here. So we have x minus 10, x plus 6. What two numbers multiply to negative 48 add to negative 2? And once again, we counted on having a plus 6, which must mean that this other one is negative 8. Negative 8 plus 6 is negative 2. Negative 8 times 6 is negative 48. And try to do how I'm doing it. I could have wrote these in either order, but try to write the things that cancel out vertically, just one on top of the other. It's not wrong if you don't, but it's just neater and cleaner that way. And then, of course, rewrite your final answer.
Couldn't you even cancel those ones negative?
Cancel.
Like if you have x minus 16, like the bottom x plus 6,
No.
does it become a zero pair?
No. No. X plus 6 over x minus 6 does not cancel. Just imagine if you plugged in a number like x equals 1, you'd have 7 over negative 5. So you can't cancel them out. It doesn't simplify correctly. Now there is a very similar situation where things do cancel out, which we're going to look at tomorrow, and that's if you have like an x minus 6 and then a 6 minus x. So if I throw in x equals, if I threw in x equals 1 here, that would be negative 5 on top, and the bottom 6 minus 1 would be positive 5. That equals negative 1. So when they're both subtraction but they're reversed, they will cancel but equal negative 1 instead of positive 1. But we'll look at that tomorrow. Alright, so as you can see, it's mostly reviewed. The only thing I'm asking you to do that's new is just how you write your answers. Try to get everything to line up vertically that cancels out. Okay? And now you have the rest of the period, it's about a half hour, so use the time wisely.